Hello everyone and welcome to this demo on value tree mapping. Today we walk through what value tree mapping is, why it matters, and how we can apply it in a mining example. We'll first cover the basics of value tree mapping, then move into an example focused on drilling cost, and finally, I'll show you how to build the structure directly inside Earth core. Value tree mapping, or what we call VTM, is a structured way to break down an operation into smaller connected pieces. You can think of it as a hierarchy where, at the very top, we place the outcome, or KPI we want to monitor. Beneath that, we identify the key value drivers, the categories that influence this KPI. And under each driver, we keep breaking down into smaller and smaller components until we reach measurable inputs. For example, in a drilling operation, the KPI might be drilling cost per meter. The cost is influenced by consumables, energy, and labor. Energy itself is influenced by fuel and fuel cost. What makes VTM powerful is that each relationship is transparent. You always see how a low-level input like fuel cost propagates upward into a higher-level KPI. This brings three main benefits. 1. Clarity. Everyone in the team can see how their area of responsibility affects the bigger picture. 2. Traceability. If performance changes, you can trace back exactly which input caused it. 3. Scalability. You can start simple and expand into more detail as your data and operational understanding improve. And remember, VTM is not about going as deep as possible. The key is to build the most transparent and manageable representation of your process. The depth can always be expanded later, but clarity is what makes the tree actionable. Now, let's move to a practical example in Excel. Let's start by examining the drilling cost per meter KPI in Excel. We begin in Excel because the very first and generic use of value tree mapping is often manual in Excel. These structures can be built in spreadsheets where each formula breaks the process into smaller components. As new inputs are added, they can be manually updated and visualized with lots of steps required. Later on, we will implement the same logic in Earth core. But for now, we want to walk through the logic step by step here in Excel. As you can see, the drilling cost per meter KPI is expressed in dollars per meter. It's calculated as total drilling cost divided by meters drilled. Once we make the first calculation, we can see that total drilling cost is made up of three components: consumables, energy, and labor cost. Notice the blue fields. These represent measurable inputs, the lowest level of the tree. These are the values that must be provided directly, and everything else is calculated step by step. For example, under consumables, we see drill bits, additives, and energy. Drill bits and additives are direct inputs, while energy is calculated by fuel times fuel cost. This means energy contributes to both consumables and the total drilling cost. Similarly, labor cost is calculated from payroll and damage cost, both contributing in dollar terms. On the other side of the formula, meters drilled are determined by penetration rate, working time, and utilization. Penetration rate is a direct input that may change daily or by scenario. Working time is derived by taking 24 hours and subtracting the breakdown hours, planned maintenance, and unplanned maintenance. Utilization is then calculated using working time, delay time, and idle time, normalizing the results as a percentage. Finally, when we roll all of this up, we return to the top KPI, drilling cost per meter. This allows us to trace exactly how prices, equipment downtime, or penetration rate impact cost efficiency. And while this example shows just one day with manual data entry in Excel, you could just as easily track it over 30 days or longer to see how each factor drives the overall cost trend. Of course, drilling is only one example. The same value tree approach can be applied to any process: maintenance, hauling, processing, finance, planning, and more. and the level of detail is completely up to you. You can keep it simple or expand into very fine-grained inputs depending on the data you have. Now, Excel is a great way to start because it is simple and flexible. But as you have seen, every time we add new drivers or input data, we need extra steps. We need to update formulas, add new cells, lots of manual steps. This quickly becomes time-consuming and hard to maintain, especially when more people and more inputs are involved. That's exactly why we bring this logic into Airth Core. Core allows us to build the same value tree structure once, connect directly to live data sources, and let the calculations update automatically. This eliminates repetitive manual work and makes the value tree truly dynamic and collaborative. Let's now take a look at how the drilling cost per meter KPI is implemented inside Airth Core. First, let me give you a very quick introduction to Core itself. Airth Core can be briefly defined as an Enterprise AI-powered decision support platform. It's a visual-based data processing and decision support platform that allows you to bring together information from different data sources and transform it into analyzable and automatable flows. It can do this in a component-based way that requires low-code knowledge and offers solutions for different needs and projects of users. By combining these components, we can build different applications, whether it's running an AI model, executing a machine learning workflow, or, as in this case, constructing a value tree mapping application. On the screen, you can see the main editor area. This is where we configure, connect, and manage the components of our flow. On the left-hand side of the editor, we start with our first data inputs. For this example focused on drilling cost, we connect the data set, say a CSV file, or it can be a live database feed, that provides the smallest measurable inputs. These are the same blue cells we saw earlier in Excel. The input nodes include variables such as drill bits, additives, fuel, fuel cost, payroll, and damage cost, and more. These are the base values that feed into higher-level calculations. Once these inputs are connected, the logic of the tree is defined step by step. For example, energy equals fuel times fuel cost. Consumables equal drill bits plus additives plus energy. And as you can see, these connections are established. Also, labor cost equals payroll plus damage cost. Total drilling cost equals consumables plus energy plus labor cost. And finally, drilling cost per meter equals total drilling cost divided by meters drilled. The important point here is that these formulas and structures are defined once in Core. After that, the system automatically manages the calculations and displays the value tree dynamically. Inputs can be static values, like a fixed number entered manually, or live values pulled directly from databases and sensors. This flexibility means part of the tree can run on static data while other parts stay connected to live operational data. Once the structure is in place, Core allows us to display the complete value tree and trace how each input influences the top-level KPI in real time. Let's have a quick look at the final results. How it's displayed in the Airth Core dashboard preview. Then we will continue with how to create it. As you can see, the final result, drilling cost per meter, is calculated for the third day of July 2025. And as you can see, there are some higher values, especially for 3 days. When we investigate the breakdowns, you can see total drilling cost has similar higher values. And when we go to meters drilled, there are 3 days specifically with the least drilled values. Expanding this calculation further, we can see and investigate extraordinary values for each item. Higher and lower values can be seen through the graphs and tables available. Firstly, let's access Core and create a project. For this, you can click the Core button on the left-hand side. After that, clicking Create Flow will open up a window. Then, the required folder selection is done, and the naming will be given. For example, VTM version 1 for now. Flow type can be UI, and no text is required for the selection. Now we access the core interface. Our general workflow is as follows. First, we need to import our example data, and then we need to build our value tree mapping in core, as we saw before. Let's first look at the data available in our hands. For this demo, we have days of results for these variables. As you can see, additives, breakdowns, damage cost, delay time, drill bits, energy, fuel, etc. These are the data points at the deepest level of the value tree mapping. What we need to do, as we discussed, is import the data first. For this, I am clicking Dataset on the left-hand side, clicking the plus button, selecting Static Dataset, and choosing CSV. I will browse the file for this demo. Its name is Value Driver Drilling Demo. I selected that one and clicked Next. There are some settings we can configure, and in the final step, the completion warning appears, and we can see our data. After that, we can click Create, and then check whether the CSV is available or not. As you can see, Value Driver Drilling Demo is available in our static datasets. Now, as we discussed, core is based on components. That's why we need to introduce this uploaded CSV into the core system via a component. For this, I am selecting the Data Access component and dragging and dropping the Static DS component here. After that, I need to select the dataset from the left side. Let's run Value Driver Demo. Now we need to continue building the following components. Before constructing the value tree mapping, we need to create another component called the docdb query component. Why are we doing this? Because we want to configure incoming data from the CSV according to each component for value mapping, and we connect this CSV file connection. There are some default settings in the select portion, but we won't change them. Now we start to populate the value tree method in Core's component section. Each item we saw before, like these ones, is called a VTM node. By dragging and dropping, we can make them available in our editor section. In the parameters section on the right-hand side, if you click the components, these pages will display according to the selected component. For the VTM nodes, our main area is parameters, and our second important area is properties. But for now, let's start with parameters. The parameters section contains settings for the component for the value tree mapping section. This component, this node, can be a dataset column, which we are going to create now by connecting this docdb query. It can be a formula, as we investigated, it can be an M function, or it can be a set value. For example, if you want to utilize a static effect rate in your calculations, you can use the static value and create it accordingly. But first, as I said, we are going to start with the dataset column. As you can see, when we start clicking with datasets or a different value type, the following settings change. Let's start by configuring the first available item, the deepest item in our calculation. Let's look at our Excel again. What we are going to configure is drilling cost per meter, and we can start with drill bits. If you want, let's configure the first drill bits node. For naming this node, I will write drill bits in the properties section. Then I will come back, as we discussed, to the parameter section again. We already selected value type. It should be a dataset column. Why? Because the data for drill bits is available in our uploaded CSV. I'm coming back to the dataset column. As you can see when you click it, this column section becomes available, and we are selecting our required column. Then we come to the reference column. The reference column is, as the name implies, the column on which the data is based. For this case, it's the date. It can have different purposes. For example, for scenarios A, B, C. It depends on your requirements. For aggregation, this section will be displayed under this node and in the preview mode. For this one, for example, let's look at max, min, and average. In this case, the first node is ready. Let's also investigate the first setup node in preview mode. For this, let's add one data grid to investigate all data. This node will be displayed in our preview mode. For this, click Workspace on the top left and click Preview Workspace. For now, as you can see, one node appears, and as you can see, all data is available as we selected. Maximum, minimum, and average values are displayed. This line chart, since it was already selected as a line chart inside the node, is also okay. When we click the component, it will open up the table below. And if we click View Table, it will open as a data grid. And if you want to view the chart, the line chart will appear in a larger window. When we go below, as you can see, all our data can be investigated. Now, let's continue building other parts of the value tree. I am again selecting a VTM node, connecting this node, and selecting Dataset column. I need to select columns for this one. Let's check, for example, Excel again. We need to add additives. Let's add additives. For this one, I am selecting additives. For the reference column, it's dates. Similarly, we'll use max, min, and average, and let's name it additives. This is also done. Let's save before we forget. Now let's continue with the energy section, fuel and fuel cost. I am again bringing nodes, connecting them, and selecting Dataset column. I need to select columns. Let's check. We need to add fuel. I am selecting fuel and dates as columns, and again average, max, and min. Save it again. For example, you can copy and paste a component by right-clicking. I am just coming again. For this one, I will delete the field and update the field as fuel cost. Now what we need to do is create a formula since energy is calculated by multiplying both fuel and fuel cost. Let's select a new drag and drop a new VTM node. Now this one has an extra step here. As you can see, there is one input area. Since we are connecting this one, you can imagine it as an input area. But for this node, we need two inputs, right? For this, we go to the Properties section and click Add for the input fields. When we come back to Parameters, what we need to do is select the value type as Formula and connect Fuel in the first input and Fuel Cost in the second input. As you can see, our inputs are available here. While creating the formula, we write input 0 multiplied by input 1. If the names are sometimes misleading, you can change these input names in Properties under the Label section. For example, name them Fuel and Fuel Cost. When we go back to the Parameter section, as you can see, these are changed. We just need to update the formula to fuel multiplied by fuel cost, and we can again select average, max, and min values. And let's change this chart type to a bar chart. Save it, run it, and investigate the results together. As you can see, all results are populated, and for the calculations in our hands, energy has 3 high values, and we can see the maximum value is 571. It's obvious that it's affected by fuel because, in this example, fuel cost is the same during that period of time. But as you can see, for energy, this value happened during that time. Also, we can see the additives and drill bits were rolled over there. Now again, let's continue building the rest of the flow. and final results can be observed in the dashboard. All right, let's wrap up this demo. Today, we started by introducing the concept of value tree mapping, a method for breaking down complex processes into measurable inputs and drivers. We then explored the drilling example in Excel to see how the logic works step by step. And finally, we rebuilt the same structure inside Earth Core. So, why is this important? Value tree mapping gives us clarity and transparency. It shows exactly which inputs drive performance and how they roll up into the KPIs that matter. It helps teams align strategy with operations and focus on the levers that truly create value. And why Core? Because while Excel works for a start, it requires constant manual updates. Core makes the value tree dynamic, automated, and collaborative. It connects directly to live data sources, ensures consistency, and lets you track your KPIs in real time. In short, VTM shows us what drives value, and Core makes it scalable and actionable across the entire operation. Thank you for watching this demo. I hope it gave you a clear understanding of how value tree mapping can support your processes and why Earth Core is the right place to bring it to life.